Another important intermediate is benzene. So let's study what benzene is. Benzene is basically a benzene ring where we have removed two hydrogen atoms. Something like this. If we remove these two, we get benzene because both of these hydrogens are getting removed. So extra pi bond will be created over here. So this is what we call as benzene. It is an intermediate that is formed in certain reactions, and this goes on to form products. So benzene is formed in a reaction which is commonly known as sign substitution. In a sign substitution reaction, we have formation of benzene. Benzene is an aromatic compound where you have two sp2 orbitals getting involved to form a pi bond. It is a rare species where hybridized orbitals are getting um, a pi bond formed. In general, hybridized orbitals do not form a pi bond. Only pure atomic orbitals such as p and p overlap forms pi bond, d and d overlap forms pi bond. But here you have two hybridized orbitals, sp2 orbitals, which are forming that extra pi bond. That extra pi bond is formed by sp2 overlap. This is the only example where we have hybridized orbitals forming a pi bond. Now move ahead. We have this reaction. This is known as sign substitution. The reagents are, you can take sodamide or potassium amide along with liquid ammonia, where you will have intermediate benzene formed. So because of which that NH2 can get attached to either the carbon at the top or the carbon at the bottom. So this is an example of sign substitution, and in this aniline is formed in 50:50 percentage ratio. That means NH2 can bind to this carbon as well as to the bottom carbon. So this is possibility only in sign substitution. Alright, next is another intermediate, and such intermediates are called as electrophiles. Electrophiles are electron loving species. Electrophiles are electron loving species. Electrophile, electro means electron and phile means loving. So electron loving species are called as electrophile. Alright. Next, you will have electron deficient species, that definitely they are loving electron. That means they are having a scarcity of electrons. So they are electron loving and they are electron pair acceptors. Electrons are always accepted or donated in pairs. So electron pair acceptor. And if they are electron pair acceptor, I think you know that electron pair acceptor species are also called as Lewis acids. So these are also called as Lewis acids. So what are the categories where we can say these are electrophiles? So electrophiles in general are positively charged. So electrophiles are positively charged species. Example, R plus, X plus, NO2 plus. These are electrophiles because positive means electron deficiency and these are electron pair acceptor species. So these are electrophiles where positive charge is there. So can we say that neutral species can't be electrophile? No. Neutral species can also be electrophiles when they can be electrophile. Either they have a deficiency of electrons or they have a vacant orbital. Alright. So you have all the species having deficiency of electrons. Species having electron deficiency are also neutral electrophiles. Example you can have BeCl2, AlCl3, BF3, BCl3. All these are Lewis acids or electrophiles. And another category where vacant orbital is present, they can also act as electrophiles and neutral electrophiles. Example, we have SnCl4, SiCl4, PCl5, SF6. So all these species, they have desired number of electrons. That means octet is already complete. In fact, they have more, but they have extra orbitals which are empty, so they can accept electrons and keep it with them. These species have electron deficiency. Here beryllium has 2 bonds, that means 4 valence electrons, and for octet they need 4 extra. Here AlCl3, they already have 6 valence electrons, they need 2 more electrons. So they are electron deficient, and these are species which have empty orbitals. So these are neutral electrophiles which we could find in different chemical compositions. So this is it for now. Thank you.